One way to solve absolute value inequalities is by plotting graphs. So what you need to do is you need to first plot a graph to represent the red part, and then plot a graph to represent the blue part. Okay. The red part is the absolute value inequality. So for graph 1, let me change back color. So for graph 1, you want the absolute value of 3x minus 1. Now, what exactly is 3x absolute value of 3x minus 1? This actually represents two pieces of a graph. One is when the middle part, 3x minus 1, is greater than 0. Okay, so that means everything inside absolute value is 0, is greater than 0, is positive. Then I want to keep the function as it is. Okay, so when do we do that? That is what I want when 3x minus 1 is greater or equals to 0. That means this is when 3x is greater or equals to 1 and x is greater than 1/3. Now, if the yellow part in the middle, okay, so if the yellow part of the absolute value function is a negative value, so if this part is actually less than 0, if it is actually a negative value, then that means I don't want to keep the function as it is. I want a negative of it. So I want a negative of 3x minus 1, which means we have negative 3x plus 1. Okay, so it breaks up into these two sections. So this is when obviously 3x is less than 1 and x is less than 1/3. So what does graph 1 look like on a Cartesian plane is I want to be when x is at 1/3, that's a critical value. Okay, when x is greater or equals to 1/3, i.e. on the right hand side, when x is greater or equals to 1/3, I want to keep the original graph, which means I want a positive gradient and a y-intercept at -1. So I want a positive gradient and y-intercept at -1. Okay, that represents 3x minus 1. Now, we're on the left-hand side of the thing. So on the left-hand side, when x is less or equals to when x is less than 1/3. Okay, so we're talking about on the left-hand side of this, I want to use this equation. That is when the gradient is -3, so it's negative, and y-intercept is 1. So we've got a graph looking like this, passing through 1 and with a negative gradient. There we go, that's your graph 1. Now, once you've done that, then you have to deal with graph number 2. Now, graph 2 is actually very simple because graph 2 in this particular case is just y equals to 2. 2 is y equals 2, right? So that means I want when y, let me extend this axis a little bit. So when I want when y is 2 over here, okay? So extending this out, extending out. And for graph 2, I want when y is equals to 2. There we go, y equals to 2. Now, for this particular inequality, I want when 3x minus 1 is less than 2, i.e. I want when graph 1 is below, is less than, so it's when it's below graph 2, below the second graph. Okay, so as you can see on the graph over here, that is when this part happens. Okay, this part is when the red graph, this is when the red graph is below the blue graph, is underneath that. So once that is, once you see that, and everything else is quite simple, because then that means how to solve this inequality. I have to find where this intersection point is. Okay, I have to figure out what this intersection point is, and your solution is all the x's in between those two intersection points. Okay, that means from here it just goes like, okay, I want to find the intersection point between these two. I know that on the left hand side of this, the absolute value graph was dissected into 2 bits. So you simply go like, okay, well, that means when 3x minus 1 is equals to 2, 3x is equals to 3 and x equals to 1. The other intersection point must be negative 3x plus 1 equals to 2, and then negative 3x equals to 1 and x equals to negative 1/3. That corresponds to this point, negative 1/3, and this point, 1. That's the 2 intersection points. Okay, so what's the solution? The solution is in between these two, because that is when the red graph is below the blue graph. Therefore, the solution is x in between negative 1/3 and 1.